Okay, so hello everyone. Thank you to the organizers for having me here at this conference. This is my first time at PyCon Sweden. I would like to talk about the match statement in Python. But first, a small introduction to myself. Who am I? I'm Marc Lemburg. I've been around for ages. I've been working a lot for the community. I've been board member of the PSF. I've been a board member of the EuroPython Society and chair of the EuroPython Society. I'm also a core developer. If you know anything about Unicode or the DB API or the platform module, much of that is due to me. And if you have any problems with that, that's due to me as well. I also have a user group that I co-founded with a friend in Düsseldorf. We run that every now and then. And I have a company called Eugenics. It's a project company. We do custom projects for clients, mostly in fintech these days. But I guess that's enough. You can go to the website there if you want to read more about these things, or the QR code there is my LinkedIn. Right, so this is an advanced talk. So first question is, how many of you actually know that there is a match statement in Python? Okay, good number of people. How many of you have used the match statement? Okay, not so many people. How many of you have used the match statement for advanced stuff? Okay, maybe like 5 people. So, but it's good that you already know that there is a match statement, and you've already, some of you at least have used it. So this is the match statement. Let me see whether this works. Yes, it does. So there are lots of things to consider here and to learn about here, because the match statement itself is really like a mini language inside Python. So what you have here is a good number of concepts that you have to learn if you want to start using it. The most important one, of course, here is the match object. So this is what you actually want to match on. Then you go into these case statements down here, and each of these case statements has a type pattern. And this is where you go and then you actually try to figure out what the different things are that you have in your object that you want to match. There are different types of these type patterns. This is a very simple one. It basically just matches a list in Python. And then you have these, what's called a capturing variable, where you can store what you've matched in a variable that you can then use inside the body of your case. So for example, here I'm using the list object to say, okay, I found the list. Down here, I have an instance pattern. This is very useful because you can actually go in and then match on class instances. And as you can see here, you can have queries into attributes of those objects that you're actually looking for. So this particular one would only match element instances that have an attribute called tag, and the value of that attribute has to be country. And then when you found this, you store it in a capturing variable down here. Next one is a sequence. Basically, it looks like a list, but it can be any kind of sequence that you have in Python. And it only matches if you have 3 elements in that sequence, and it stores the values of those elements in the variables A, B, C. Here you have an extra feature, which is called a guard. So basically, this case statement will only match if you have a 3-element list or a sequence with B, the second element in that list, greater than 3. So only in that case you go into this one. We have a very similar thing for mappings, and you can even do things like ** more to capture all the remaining data into something that you then want to continue to use when in your parsing. Plus, of course, you have a wildcard. If you look at the documentation, it typically says to use an underscore for this. I don't like the underscore very much, so basically I always use just a random capturing variable here. Because it's the last case statement that you have, this will always match because there's no condition there, there's no type annotation there. So unknown will always match, and it will store the value that you've matched there, the object that didn't match any of the other case statements in unknown. Right. So that was a short recap of the match statement. Now, the reason why I'm giving these talks at conferences is because I want to make the match statement more popular. Because if you look on PyPI and you look at the language features that are being used in packages on PyPI, you find that the match statement is only being used by 0.5 or 0.6% of all the packages on PyPI. This is data from July 2023. There's a great website for these things. It's called py-code.org, where you can get all these statistics. Unfortunately, the person maintaining it hasn't updated this recently, so the data is not quite up to date. But I guess nowadays maybe it's a bit more than 0.6%, but probably not much. So there's still a lot to do, lots of talking about these things, making things more popular. The greatest problem with all of this is that there is no good documentation. Basically, these are the PEPs that define the match statement, but there isn't a lot more in the Python documentation that goes beyond what's written in these PEPs. And if you go on the internet, you only find very, very simple examples of how to use the match statement. But it's actually quite powerful, and it's a really nice feature that we have in Python now. So these are some of the things that you would typically do in advanced parsing, some of the concepts that you typically don't read on the internet. So very common here is to use an OR pattern, so you can match on multiple different values here. You can have all kinds of parsing of optional things, like for example here you parse basically a list with an arbitrary number of elements, and then you're just interested in the first two. The first two have to be 1 and 2, and then the rest you store in args, and you can do something with it. Here you have a list with 4 elements, and you're just interested in the first and the fourth one. Same for mappings. You can do this, like I mentioned already. Then you have the instance parsing, which is very, very useful, especially when you go deep into the attributes of those instances that you have. You can also mix local variables that you have with capturing ones. So if you look in here, then you will see that there is a capturing variable down here, the type name, and then there is a local variable that you're using in here called params.varname. And the difference here is that params.varname has a dot in it. And the dot makes the logic of the match statement know that this is actually a local variable to look up in the local scope that you have. It's not a capturing variable, because you have to make that differentiation somehow. And that's what was chosen. So the dot basically makes the difference. If you want to know more about these things, there's an excellent talk by Raymond Hettinger. He gave that talk at PyCon Italia in 2022. And you can also get the slides and then have a look at that. So next, I'm going to show a few examples. I just have to check the time. Okay, so it should work out. These examples actually show a lot of code. Unfortunately, the text is a bit small. And that's why I put everything up on a GitHub repo. The QR code up there takes you right to the GitHub repo if you want to download the slides. You can also look at the code there directly in the .py files. The QR code is going to be on all the next slides, so you have enough time to basically access it. So I'm going to start with JSON. I'm going to give 2 examples for JSON, then XML, and then AST, and which is the most complex one. Right, so JSON, a very typical kind of data that you get is tabular data. And this is a very, very simple example. It's like prices of eggs that you can buy. I intentionally also show data that is not clean, because if you do data engineering, then this is basically your daily job. You have to work with, well, unclean data. In this case, you see there's one row there that doesn't have a price. There's another row here that has an extra field. which you don't really define in your schema. So you have to deal with these things on a daily basis. And of course, you want to be able to have your parser handle these cases and not just simply fall over. So I put everything into dictionaries and then turned it into a list. You can imagine that you can write this down as JSON and then parse it using the JSON module, and then you get this dictionary with the list with the dictionaries. So this is how you would parse this using the match statement. And it's actually quite straightforward. So you start with, over here, with you take the instance that you get. You look at the instance, what you expect here, because you just want to parse one record, you expect a dictionary. So if it's not a dictionary, this case would not be matched, and instead it would go down here, and you can do your error handling down here. So this is a very nice way to basically do error handling. You don't have to use try except for these things. It's much easier this way. And then once you know it's a dict, you can have another match statement, and then in that match statement, you basically pull apart this dictionary. And what I do here is I try to match a name entry in there and a price entry in there. And then if I have any extras, I put them into extra, and then I can do some extra processing here, maybe give out a warning that I have extra fields that I don't know anything about. Or I can then go straight down here to process the data. I'm just printing it here. What's also nice about this is that you can actually not only parse the data item, but you can also convert it into a particular type that's easier to process. So for example, the name would always be a string. Because you're getting a string anyway, you can just leave it like this. But for example, the price might be an integer or a float. So what you can do is you can do the implicit kind of assignment to a capturing variable by putting the price in here into the int, the type declaration. And then you can say or, because it could be an int formatted as an integer. Could be a float that has a decimal point, right? So you want to capture both ways of doing this and not lose any data. Right, so this is a very, very easy way to basically parse a single record in JSON. And then if you have multiple records, of course, you would then take the list with all the instances that you have. And again, you do the case list here. And then you just do a for loop and then go into a separate function to parse the elements themselves. And again, you have this error handling down here. So very easy. Another example. This is a bit more involved because it has nested structures. What you do here is you're parsing GeoJSON data. And this is actually from the website here. It parses the location data of a tiny island in the Philippines. You see here you have a type declaration, you have a geometry declaration in here, which basically says which point this is, and then you have certain properties, so you give it a name, for example. If you want to do something like that, it's basically very much the same thing. You go in here, you take the instance, you figure out the type. What I'm doing here is I'm basically checking the type first. So the type value that I'm getting here has to be one of these GeoJSON types. If it's not one of these types, then I cannot parse it and I have to do something about it. So basically, I'm just saying, okay, I can't do this. If it's one of the valid types, I go in here, and in here I take the dictionary that I get from other members over here, and I parse these again in a separate match statement. And if you read this, it looks very natural. I mean, if you compare this to the data that you're getting up here, then this is a very, very straightforward way to write things. It's very readable. It's just nice to work that way. Right, how many of you love parsing XML? Okay, not that many. So yeah, this is an example of XML. It's taken from the Python standard library documentation for elementary. Elementary is probably the most used parser that you have in Python for XML data. If you want a faster one, you can use LXML. What's special in this one is basically it looks very much like data that is tabular, except for these entries. There can be one or more entries of these neighbors, and so that makes it a bit more difficult to parse. Now, what I'm doing here is basically I'm not showing this here on the slide because it doesn't fit. What I'm using is element tree to actually parse the XML, and then I basically walk over the element tree that I'm getting, and getting all the data out of it, and then putting it into a dictionary over here, countries, that basically then stores everything in a way that I can process later on. So again, it looks very, very natural. You go over here, you have a for loop that basically scans over the tree. Then you match every child. You can do the instance matching here. Element tree uses the element instance for all the nodes in the tree. And then I'm only interested in the tags that are named country. And then I'm extracting the name, which is listed as an attribute over here of the record, and putting that into a local variable called name. Plus, I'm basically storing everything in country. And then what I do here is I go into the country and then parse the country entry. So basically all the children that you see over here in that record. And where's my cursor? If you go here, you see that I'm also converting everything into proper data types. Down here, I'm handling the case that I have one or more of these neighbor entries in here. And I'm basically parsing each of these neighbors and then putting them into a dictionary that I create for this, the neighbors dictionary that I have over here. And at the end, I put everything into another dictionary called countries, and I can return this and then process everything. So that was a bit more complex. So now we're getting into the weeds, basically. How many of you know what an AST is? Okay, maybe like 1/3. So an AST is basically a tree representation of a program. And what you see here on the right, this is actually the AST that Python generates when compiling Python code. And the way that you read this is you go up here, you have a module. So this is a Python module. Then the Python module has a body. And in the body, you have, for example, a function definition. And it goes in here with the function definition. This is what you see here is the AST for this particular example that you see here, right? So you have all the details that the parser will need in order to basically compile everything and turn it into bytecode down here in this tree. And it's really complex, right? And if you want to write a parser for this using the standard, like, if chains with is instance and stuff, it's going to look horrible if you do that. Now, the idea here, because I wanted to have a more complex example, is I want to automatically convert the function over here into a version that uses the match statement instead of these if chains. So this is a bit more complex. I don't have a lot of time, so I'm basically going to rush a bit. Sorry for that. So first thing I do is I go in here, I take the function. The function is going to be the function object, so I use the inspect module to get the source code for that. I pass the source code to the AST module, which does the conversion to the AST, and then I get a tree. What I then do is I go into that tree. I'm just interested in the functions in there. So if there are any global variables or so, they will just stay there and I won't touch them. I just want to look into the functions. And then I go in here, I find a function definition using the match statement. Again, I'm using the instance pattern here. I'm extracting various arguments in here. This looks a bit weird because it actually is a bit weird that this is how the AST represents arguments. So it's deeply nested, as you can see here. I'm storing the name of the variable in varname. And then I basically branch out into a new function called function refactor, which you see here, to actually refactor this function. So when I enter this, I know that I have a function, and then I can continue parsing the node knowing that I have a function. And I go here, I go into the function body, and then try to find the if statements in that function body. Again, anything else will be left untouched, right? So it will just go in here and then work on the if statements. So what I do here is I basically find the if statements, and then I have another function called scanif, which then basically analyzes the if statement and figures out whether I can process those, whether those can be turned into a match statement. And I go into this extra function if-refactor to then do the refactoring. And as you can see here, only in the case where I have actually found something that I can process, I then use the node and put them into a new body that I then eventually store as the new function body. So what happens in the scan function is I go in here, I try to figure out whether the if cases that I have in there actually are compatible with what I can do in my algorithm to convert them into a match statement pattern. I use a little trick here because of this dot that I need for local variables. So basically I just have an empty class, and then I put the var name in here. The var name is the variable name that I have as the argument of the function. I need that because I need to know what the match object is called. And so what I then do is I go in here. I know that a test is one of the tests that I do in an if statement. Maybe a small aside. There is something that is a bit strange when you work with ASTs. If you write the if statement and you have if-elif-else, right? So it looks very linear. But the AST is actually, it's a tree structure. So there is no thing like a list in there. What you do is you have an if statement that has a regular case and then it has an else case. And then if you do the representation in the AST, it's actually a tree. So if you have an if, elif, and so on, you start with a single if statement in the AST, and then the else branch is another if. And the next else of that if is also an else. Sorry, the next if that you have in your chain is also then in the else branch, and so on and so on. So it goes deep down. Just so you understand how this works here. So what I do is I have two types that I know how to convert. One is I basically use the is-instance function to figure out whether something is of a certain type. This is what I would write in the if statement. And then I have a second case where I'm also adding a condition down here. And the way to figure out this one is actually quite easy. I'm just looking for calls to the is-instance function, and then I'm storing this as a new case. In the second version, I know that I have an AND because I have is-instance and a condition. So basically, I look at the left side of the AND. The left side has to be an is-instance, and the right side has to be the condition that you see down here. Right, and so those two cases I can handle, and I know how to convert these. So what I do here is I then basically just have to take care of this recursive scanning that I just explained with the chains, so that I can actually catch everything. And I collect all these cases in a list, and the list of the cases is then passed into this function, if-refactor, and this takes the cases and converts them into new AST nodes, which are quite easy to build if you know which kind of AST objects you need. You just build this, you append it, and then you return this as new match node. And then if you go back here, you see that this node is being returned, and this is being appended down here. So this actually replaces the body. And so this was a bit more involved, but what it actually does is automatically converts from here to here. I could show you as an example. It's very interesting if you see that happen in real code that actually has lots of other code with it, and then it just goes in and replaces the ones that it can find. So this all looks great, right? You'd want to use it. There's one catch with it. It's a bit slow. So I ran some benchmarks, and I basically compared the if variable if you write everything using an if with the match variant. And you can see here that it's actually about twice as takes twice as long to use the match variant. There's one case that's actually quite nice, which is a list of integers, for example. It's actually faster in that case. So if you have a list of integers that you want to match, then the match statement actually shines. What I also find is what looks like a performance bug, because there is a huge difference between parsing the generic capturing case. Generic is the case and then type and then as the variable, versus the inlined one, where you basically put the variable directly into the type declarator. As you can see, there's a huge difference there, and it doesn't look right. So I'm going to have to open a ticket for that, and maybe this can be fixed. So basically, to recap, it's about 2 times slower. It shines for sequence matching. Why is it slow? Because it's still the first implementation. The implementation hasn't been touched since 2021. So if you like to dive into this, you want to get into core development, then this is a good example. And you can really shine if you can make this faster. And it should be possible to make it faster, because there's lots of low-hanging fruit there that can be used to make things better. But even though it's not fast yet, I mean, it's very typical in Python that you first start with a concept, you implement it, you give it to people, people start using it, and then you worry about performance, right? And so this has happened in Python a lot. For example, if you used Python 3.0, it was basically unusable because it was so slow. But nowadays, it's actually quite fast, and it's getting faster all the time. So what is important is readability, because this reduces maintenance overhead, and this reduces, getting into complexities when you have to hand over to other people and have to explain to people how code works. I mean, of course, you have to write documentation, but, it's always good to have readable code, right? So instead of writing this stuff on the left, you can just write this stuff in the middle, and then you're happy, right? So main takeaway, never stop learning, and always try out new things. These are the resources. I won't let you go just now. This is the GitHub repo over here. I can't find my cursor. Where is it? Anyway, there's the GitHub repo. For the benchmarks, I wrote a new package called microbenchmark, which makes it very easy to write micro benchmarks. Oh yeah, I'm standing in front of the QR code. Maybe I shouldn't. Yeah, you can get the resources here, and thank you.
Thanks, Mark. Any questions from the audience?
There's one here.
Thank you for your talk. Very interesting. If we disregard from the performance, do you envision that we should use match case in most if statements situations, or are there special cases where we should still keep the if-else?
There are probably certain cases where the if statement is still better. But frankly, I cannot really imagine a lot of those. If you have long if-elif kind of lists, then you should definitely have a look at whether you can convert that into a match statement.
And how about simpler, like if you just have 3 cases or something? Is it worth doing a match case, or where's the cutoff?
Probably not. If it makes the code more readable, then yes. But if it's just a simple if statement, then no.
Thank you.
Thank you for your talk. Really interesting. Kind of inspiring to see that case statements isn't just like spicy if statements. But I think it was on slide 19, on line 9 or something like that. You did some capturing.
What was it? 19?
Yeah, slide 19 about the AST parsing or matching.
This one, yeah?
Yeah, exactly. So for example, there you did the trick for non-capturing vars by defining empty class and then defining var name, and using that on line 9 during rx name id equals params.var name. Yeah. Could you just as well use put it into f string in case id is a string to avoid using capturing by using var name?
Well, I actually want to have I mean, these are just examples. I mean, I could have done it in other ways as well, but I typically want to have the values in local variables so I can do logging and reporting and these things. It may not be necessary to always put them into these capturing variables, but you know, why not?
Yeah, makes sense. Thank you.
We are running short of time. Mark will be around. I think, I mean, you can maybe take it directly with him for now, but I think it's time for the next speaker.
Thank you.